Color vision is a synthesis of red, green, and blue light, which is brought about by changes in pigments within the cone cells of the retina. The human eye can recognize hundreds of different colors, which are combinations of these three colors. It is believed that three specialized types of cones exist, one responding to red light, one to green, and one to blue light. Some of these cones, however, can be stimulated by the whole visual spectrum. The variable stimulation of all the cones can register all of the colors known to man. Absence of or defects in the cones that respond to red, blue, or green light causes various types of color blindness. Colorblind people may not be able to see green and red, blue and yellow, although blindness to blue is rare, or any color at all, with everything appearing gray.
We check as pediatricians in a routine eye exam, we usually do it around 4, for color vision. What group of individuals could be colorblind, and what does colorblindness mean?
Well, color blindness, it should probably be changed to color deficiency. And most color deficiencies that we see in the general population are something called X-linked recessive, which means that the problem is carried on the X chromosome of the female. So the male has really no ability to pass color blindness onto a son. The son would have an X and Y chromosome, and the female would have an X and X. So a father can only pass color blindness down to his daughter who has an X chromosome. A mother can pass it down to son or daughter. If you are a child who happens to be male, who has the colorblind gene on the X chromosome, you're going to be colorblind because you only have one X chromosome. If you're a female who has one X chromosome that's colorblind, that has the colorblind information, and the other X chromosome, which is normal, you would be a carrier. You wouldn't have color blindness, but you could pass it down to your child. The female needs two X chromosomes which are affected to have color blindness. That's why it's seen more commonly among males. It's a X-linked recessive gene, and because of that, males have it more commonly. The type of color blindness that's seen more commonly in the general population is red-green color blindness. That happens probably in the general population of males in about 5% of males. There are different types. To understand color blindness, you have to understand that there are three main receptors or cones in the human eye that affect color. We can call them S, M, and L, but they're also known as red, green, and blue. It's more common to call them, it's more correct to call them long, medium, and short because that corresponds with the wavelength of the actual color. Depending on what is wrong with your particular receptors, if you have a deficiency in some of the chemicals which function to cause that cone to fire off, you'll have either a red-green color blindness or, less commonly, a blue-yellow color blindness. Red-green is much more common. If you have a red-green color blindness, it doesn't mean you can't see red or green necessarily. It means that your ability to see it is lessened. And you might see a red color as being a washed out red or pink, and you might see a green as being not really the green that a normal person would see. This might not allow you to see colors properly, but you can still sometimes distinguish that they are red or green. For instance, if you have a blue sweater versus a purple sweater. A purple sweater is made up of fibers that are red and blue. A blue sweater is made up of blue fibers. The person who has a red-green color blindness might see those two sweaters as being the exact same color because the red is washed out in the purple sweater and it looks like blue to them. So depending on what type of color blindness you have would be determined by the amount of effect it has on those receptors or cones in your eye. If none of the cones work, you could have a disease called achromatopsia where you have horrible, horrible vision. That means that you have 2 to 3 of the colors not working or not present, or the receptors are not working. Those cones, if they're absent, would cause you to have severe vision. All the cones are centered in the center of your macula, and if they're missing and not functioning, you would have vision no better than 2400. And you would have nystagmus, which means your eye would shake, and you would also have severe photophobia or sensitivity to light. That's a very rare condition, and it's called achromatopsia. People who have achromatopsia have very poor vision, and it's a very rare condition, thankfully. The majority of people have what we call deuteranomaly, or they have deuteranopsia. They also have protanomaly or protanopsia. Those have to do with the deficiency of red or green. Tritanopsia or tritanomaly, which is another type of color blindness, has to do with the missing of the blue. That's much more rare. That's not X-linked, the one that affects blue, but it is an autosomal trait that's not passed on by the X chromosome.
Is there any way of that being treated down the road?
No, unfortunately, it's not right now. We don't have any means of treating it. It's because you're missing something that's not there. And to replace it, you'd have to do it on a very cellular level. If you don't have the pigment or the neuroreceptor and you don't have the cone that corresponds with the color, there's no way right now of changing that situation. But remember, people that have red-green color blindness or color deficiency, they really aren't restricted in their life in too many things. Obviously, there are certain jobs that you want to keep them away from. You certainly wouldn't want somebody who had red-green color blindness to be a fashion designer or an interior decorator because he wouldn't have a very good knowledge of colors. You might not want him to be a bomb diffuser either because I wouldn't want him cutting the red or green wires on a bomb. So there are things that you would keep them away from, but it's certainly not going to restrict them significantly in life.
And if you're wrong with it, you will not even know you had a problem until someone checks for it. Is that true?
As a matter of fact, I had a patient come into my office a few years back who was coming in because the police department had failed him on a red-green color, on a color blindness test. And he came in with his grandfather. So his maternal grandfather. I didn't know this, but I had asked him, does anybody in your family have red, green, or color deficiency? And he said no. So I said, are you sure? Because usually it would be your mother's father or your mother's brother. And he said, well, hey, you know what? My grandfather is sitting outside in the waiting room. Why don't I call him back in here and see if he knows anything about it? The man came into my office. I asked him, and this man was in his 60s. I asked him, are you red-green colorblind? And he said, no, of course I'm not. I gave him the red-green colorblindness test. He was red-green colorblind. He was already 69 years old. He didn't even realize he was colorblind.